followed. Vertical line from point O dash, horizontal line from point O. This is point O. Apex point O would be somewhere here, exactly at the center of the circle. From that point, draw a straight horizontal line, and both these lines will meet at one point. So this is the point, that is point O, apex point. Similarly, point number 5. So vertical line from point 5 dash, like this, and horizontal line from point 5, vertical line from point 1, horizontal line from point 1. So here is point number 1, and point number 5. Similarly, point number 2, 2, 3, 4, 3 and 5, vertical line from point 3 and 5, horizontal line from point 3, 5, 3 and 7. 3 point is here, right? So point number 3 would be here, point number 7 would be here. Similarly, the points 2 and 4 could be located like this. Horizontal lines from 2 and 4, that would be like this, and vertical lines from 4, vertical line from 2, vertical line from 8 and 6, and horizontal lines from 8 and 6, like this. So all the respective points could be located. Here is point number 2, 3, here is point number 4, 5, point number 6, 7 and 8. Now if we are looking from here, from top, this circular base will not be visible. It is away from us. So that should be represented with the dotted line, and so this 1, 2, 3 point and 1, 8, 7 should be joined with the smooth curve. It would appear like this. Join this base with the smooth curve, and on this side 4, 5, 6, these points will not be visible. So join these points with the smooth curve as well as with the dotted line, like this. Now the edges could be represented by joining O to this tangent. Take one point as O, another point which is tangent to this ellipse. So it shows the top view of this solid. This is, now you can name the view. This is front view and this is top view. You can insert the dimensions if needed. So that is the solution of given problem. I hope it's clear to you. You can also express or draw the axis in top view as well, like this. This is the axis in top. Now next, example number 5, based on sections of solid. And here sections of solid for cylinder is taken. So let me see the video clip of this problem.
Section of solids, cylinder. A cylinder with 50 mm diameter and 65 mm axis length has its axis parallel to the VP and inclined at 30 degrees to the HP. It is cut by a cutting plane perpendicular to the HP, inclined at 30 degrees to the VP and passing through a point P on the axis 25 mm from the top end. Draw the top view, sectional front view and true shape of the section of the cylinder. Adjust the scale of the mini drafter so that it matches the horizontal line of the drawing sheet. Mark XY line. Now mark the horizontal plane HP below the XY line and the vertical plane VP above the XY line. Construct the top view of the cylinder of diameter 50 mm such that the axis is perpendicular to the HP. Now draw its front view with height of 65 millimeters. Now tilt the axis at an inclination of 30 degrees to the HP and draw its front view and top view. Project the lines vertically from the front view to get the top view as shown. Now project the lines horizontally from each point of the circle as shown. Mark the intersection points as shown. Now join the points with a smooth curve. Mark a point P' on the axis 25 mm from the top end. Project this to the top view to get point P. The cutting plane is perpendicular to the HP and is inclined at 30 degrees to the VP. Therefore, draw the 30 degrees inclined line to VP through point P in the top view. This cutting plane cuts cylinder at points 1, 2, 3, 4, 5, 6, 7, 8, and 9 in the top view. Project the section points to the front view and mark those points as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, and 9 dash. Now join points 1 dash through 9 dash. The portion inside this loop is the sectional front view. Join points 3 dash to A dash to C dash, 7 dash to G dash, and F dash to G dash by thick lines. The cutting plane is not parallel to the VP. Therefore, the sectional front view will not represent the true shape of the section. To get the true shape of the sectional front view, make the cutting plane parallel to the VP. Project all the points of the front view to get the true shape of the sectional front view. Draw projection lines from 1 through 9 from the cutting plane and also from 1 dash through 9 dash in the front view. Mark each intersection point as shown. Join 1 dash through 9 dash with a thick line. The hatched portion shows the true shape.
Now example number 6. The data is given like this. A pentagonal pyramid, base 25 mm, sides and axis 60 mm, sides and axis 60 mm long, is standing on its base on HP, on one of its base side such that the base on pyramid inclined at 45 degree to HP. It is cut by a cutting plane passing through the midpoint of the axis and parallel to horizontal plane. Draw its projections and sectional views. So in this problem, the given data is this one. In short, we can write the given data: pentagonal pyramid 25 by 60, base 45 degree to HP, cutting plane through axis, midpoint, and parallel to HP. So first, draw XY line, which represents intersection of HP and VP. This is a pentagonal prism, pentagonal pyramid, and here in this problem it is given that it is cutting its base is 45 degree to HP. So we have to draw the pentagon in such a way that one side should be perpendicular to XY line. So first of all, draw XY line, and then below XY line draw a line segment 25 millimeter and complete the pentagon like this in such a way that its side is perpendicular to XY line. Now locate the name endpoints A, B, C, D and E, the endpoints on the base of the pentagon. Locate its axis, so for that join the corner with the midpoint of opposite side, say A to midpoint of CD and midpoint of AB to D. This is the apex, the center line will pass through this point. So draw a center line that will pass through this point, and height of this solid is given as 60 millimeter. So at a distance of 60 millimeter from this base or from XY line, mark a point on the center line, and here is the apex point. Now from this point AB, CE and D, draw the projection lines and draw a triangle like this, and this triangle shows front view of this pentagonal pyramid. Similarly, this edge OC and or OE would be here. OE would be invisible, so can be represented by the dotted line, and OC is visible, so joined with the full line. So two lines would be there, and hence we have to give priority to the full line. Now here it is given that this A dash B dash would be here, C dash D, E dash would be here, and D dash is here. Apex point O dash is here. Now the base 45 degree to HP is given, means we have to redraw this solid in such a way that this base A dash, B dash, C dash, D dash and E dash makes an angle of 45 degree with XY line. So draw a line at an angle of 45 degree with XY line, name the points A dash, B dash, C dash, E dash and D dash like this, and transfer the points by measuring the distance from front view and redraw this triangle like this and transfer respective points. Now I am skipping this problem for the next time. You draw this solution of this problem by taking projections from front view to the respective top view. In today's discussion we have solved various problems based on projections and sections of solid. I hope you have learned some of the problems, and we will continue next time with the solution of more problems. Thanks to all of you.